Okay, part three will be dilation. So, first question, is a dilation an isometry? Well, a dilation makes a shape bigger or smaller, so the answer to this question is going to be no. Because even though it's going to be the same shape, it's not going to be the same size. Now, the image and the pre-image. The best way to think of it is that when you're trying to find a scale factor, how much bigger or smaller it is, we're going to have the image on the top, always, or the copy on the top, whichever term you like. And the pre-image is going to be on the bottom. So it's not big over little or little over big. It's literally the copy goes on top and the original goes on bottom when you're trying to figure out the scale factor. Okay? So if we look at our first example, okay, we have the copy is the blue shape, so that's going to go on top, and the original is the black, so that's going to go on bottom. So that's how we get a scale factor of 2. Okay? Now, if the scale factor is greater than 1, we have an enlargement. That's how we know it's getting bigger, because the scale factor is bigger than 1. On the flip side of that, if we look at this second example, the image is smaller than the pre-image, right? That means it's a reduction. And if we set this up, this is the image, the copy. So that goes on top this time. 2 over 8, that's 1 over 4, okay? If the dilation is, the scale factor is between 0 and 1, so a fraction or a decimal, you're going to have a reduction, which just makes the shape smaller. Okay? Now, the only thing to be careful of when the center of dilation is not in the center, it might throw you off a little bit. So if we look at this one, the copy is the blue one, so clearly the shape is getting bigger. So we need to put image over pre-image. Okay? Now for this one, the pre-image is clearly 4. Right? The black triangle looks like the hypotenuse is 4. Don't get confused on this one when you look at x prime to t prime, because you would need to count the whole way. So instead of it being 8, it would actually be 12. So the scale factor here is 3. And because the scale factor is bigger than 1, we know it's an enlargement. Now you try this one. Again, the center of dilation is at O, which is the origin. It is not in the center of the shape. So don't let that throw you off. Okay. Now if we look at problem 6, finding a dilation image. So we're trying to find the copy. We have the vertices of PZG and the center of 0, 0, and a scale factor of 2. Okay, so let's start with the center. So we can just do it in order. P, how far away is P from the center? Well, it's 2 to the right, and it's not up or down. So if our scale factor is 2, that means it's going to be 2 times as big, right? So instead of it being 2 to 0, P prime is actually going to be at 4, 0. Oh, sorry. For Z, Z is 3 to the left, so negative 3, and up 1. Okay. Scale factor is still 2, so if we wanted to find Z prime, we got to multiply both numbers by 2. So we got negative 6 and 2. So that's going to be here. Notice, because the center is not exactly in the middle of the shape, the new prime points are not equidistant from the center. P is closer. P prime is closer than Z prime. Okay. Last but not least, we got G. That is at 0, negative 2, Scale factor of 2, so G prime would be at 0, -4, which is off this. Nope. Oh, no. That's 3. So it would be off the grid a little bit. So let's imagine it's down here. And then we're just going to connect the points. So that triangle should be 2 times as big as the smaller triangle. Okay, and this is going to be the classwork homework. I think I'm going to make it extra credit since we have to take the test so soon. So this video is done.